So after playing around with my proposed idea for a measurement system, a few things have occurred to me which probably should have been obvious from the beginning. Um, Basically, the when you have a speed of light that is not 1, when you have a measurement system wherein your speed of light is not 1, the the magnitude of that value that you get is actually a measure of how wrong your measurement system is. What I mean by this is your your distance and your time unit should be cooperating. They should both be relating to something physical and the same thing that's physical. So when you have something larger than 1 being your value or smaller than 1, either way, when it's not 1, what it means is you haven't actually calibrated your measurement system to anything in physical reality. It's just it's just random arbitrary, um, which makes sense, right? Because what it means, what the speed is some distance divided by some time. So the only actual speed limit in the universe, right? The only thing that has a constant speed is light. So that's the only thing that you should ever look to as your standard for looking at speed, time, and distance. That's the only thing you should ever look to as your standard for those things. So what ends up happening is, so in metric, right, the speed of light is 299,792,458 meters per second. What that means is the disparity between our length unit and our time unit is on the order of 300 million. We're off by about 300 million times. And this has a knock-on effect with energy and mass, because the disparity between those two is the square of that difference between distance and time, right? Because of the mass energy equivalence that you get from E equals mc squared. The c squared is where the squaring is coming from, right? You get energy is proportional to mass at a relationship of whatever your distance unit is to your time unit squared. So if your distance unit is off from your time unit by a factor of 300 million, which is basically what metric is, then your energy unit and your mass unit are going to be off by the square of that, which is on the order of 9 times 10 to the 16th power. It's a big ass number. Yeah. What these values are actually saying is that this measurement system is garbage. It's not based on anything. We just picked up random things that made us feel good, made us feel warm and fuzzy. Fundamentally, what it means is we're really, really slow. Really slow. And we're really bad at using energy. We don't really understand how much energy there is. We have no clue. We don't grasp this, right? Because our distances scale to our time. We're off by 300 million. You know, A meter per second. Traveling a meter per second, that's a fair clip on humans. It's not fast by any means, but it's you got to be paying attention to that to keep up with it, to keep up with tracking it with your eyes. And if you look down for a minute, something moving 1 meter per second that goes past you, pretty soon it's gone. It's out of sight as far on human scales, as far as we're operating. So, for us, that doesn't seem like such a pathetic sort of system, right? Meters and seconds. Like, okay, they feel like they talk to each other fairly nicely. But what the speed of light is telling you is that really 300 million meters fit inside of a second. Or as far as a meter is concerned, a second is 300 million times too big. And as far as a kilogram is concerned, a joule is 9 times 10 to the 16th too small. Right. So fundamentally, it means that your unit system is broken. And this is setting aside things like the fact that we measure cosmic distances with things like parsecs or light years, which are purely bound to our own planet. Both of those are bound to our own planet, and they don't make sense for any other location or source or origin or anything outside of our own solar system, outside of our own little lives here on this rock, right? If we ever get to the point where we are, even like a multi-planet civilization out off of the Earth within the solar system, let alone in an interstellar or galactic scale. Yeah, that's a weird unit. It would be strange for that to be successfully passed down for very long, because it doesn't really make sense in the context of anything. It's just this random ass, Yeah, yeah. If you're making a unit system, and you're seriously making a unit system, um, at at this point, of knowledge, where we are perhaps on the brink of expanding beyond our own planet, it should be based on things like the speed of light as a standard. Because all four of those units there's kind of a couple other things that come along with it, but time, distance, mass, and energy, all four of them end up being related to each other. They end up being perfectly related to each other if you use the speed of light as your standard, which makes sense because it's a constant. It doesn't matter how you're moving through space. It doesn't matter where you are in space. The speed of light is always exactly the same. So it is something that you can always use as a reference. You can always use to calibrate your equipment, your measurements. You can always use it. It would be retarded to use anything else as your standard. But we do. We use basically everything else as our standard, instead of using the one thing that we should use as our standard. And as a result, our time and length units are off by a factor of 300 million, and our mass and energy units are off by the square of that, which is a ridiculously large number. Yeah, so I just thought that that's something to throw out there as an expanded criticism of not only metric, but this is a criticism of every human measurement system that has ever occurred before. Uh, it's very much, it's very much anachronistic for all of them because they were all developed before this knowledge existed, before this knowledge was possible. But looking back, yeah, we fucked up. We fucked up. I was actually fiddling with the system that I proposed, and I was surprised. I shouldn't have been, but I don't know. I just hadn't thought it through correctly. I was surprised by the relationships that were coming about. And I was like, why am I getting these things here? Why is this what's happening? And I had to stop and have a think, and it's like, oh, yeah. It's because, so I was kind of like trying to take the system that I had developed and convert it into metric, just kind of as a sanity check to make sure that it was possible to convert it into metric and then back, to make sure that that I had calibrated everything correctly, everything was set up right, and I had made quite a few mistakes. I kept being off by a factor of 10 with the distance units for some reason, and it would vary. It would be 10 times too big and then 10 times too small. Like, it was driving me crazy, that sort of a thing. The digits were right. I just kept putting the decimal in the wrong place, right? I don't know. But I finally got it right, and I finally got it correctly calibrated, and I could go into metric from it and back, and it was working really nicely. But there were some weird behaviors that I was seeing, and oh shit! After thinking about it for a minute, shit, that's what it is. It's because metric is built wrong. What this is actually telling me is that the meter is 300 times too small, which is exactly what it's exactly what that is telling you when you're looking at the speed of light. It's telling you that 300 million meters go into a second. That's exactly what that is telling you. It's just I'd never thought of it in that way. It did never occurred to me, even though I know perfectly well that is what a division is. It's how many of the numerator go into the denominator. That's exactly what it is. But yeah, I just hadn't processed it in that way, because I'd always just thought of the speed as a value, and there was no internal logic to it, I think. And yeah, this kind of just broke my brain. I was like, what? Oh, there is internal logic. There is internal logic to this. I mean, and it was the same internal logic that I was playing with, so it's kind of strange that it confused me. But it did. It definitely caught me off guard. I was like, oh, yeah, what this value is a measure of how wrong this measurement system is. Right? It's a way of indicating how fucked up this is. And this is unlike my criticism of the mole, where like Avogadro's number, or is it really Avogadro's number anymore because it's been defined to something specific? Like, whatever. It used to be Avogadro's number when I was a kid. It was Avogadro's number. We didn't know the number. Right? My criticism of that is, well, you could have just picked a number, and in doing so, you can choose qualities in that number that you like. Like, so if we want to make little boxes of, cadmium, pure cadmium, we can define this number so that it's a perfect cube, right? So that we can make perfect cubes of elements, exactly, down to the atom. It's exactly perfect. We could do that. But that's not what happened. We just like, yeah, here's this. We don't know what the number is exactly. It's in this ballpark. I mean, and to be fair, it was measured pretty goddamn precisely. It's just you couldn't get all the way down, and they just kind of gave up. They're like, fuck it. This is what it is. And it's just we'll say it's this. It's which makes sense. That's not a bad move, but if you're gonna just have some random ass number, you can pick it. But with the speed of light, that's not even a number that you should be picking. That's a number that should just be 1, regardless of what your time unit is or what your length unit is. Your length unit should define what if you choose your length unit first. Your time unit should just be how long it takes light to go that far. That should be your time unit. And if you choose your time unit first, then your length unit should be how far can light travel in that time. That should be your length unit. And as a result, your speed of light is 1. It's not even a number that you picked. It's just a fact that falls out of it. And your relationship between your energy unit and your mass unit is also 1-to-1. And that's not something that you choose. That's not a number like Avogadro's number. It's just something that falls out of it. And, you can't really choose 1 for your number that corresponds to Avogadro's number in a usable measurement system, because that would mean 1 atom is your volume and your mass unit. Like, that's stupid. That's stupid. You need to scale that up. You need to choose a way to scale that up. So you need to pick a number for that. So you should be smart about that and pick a number that has nice properties. I, at this point, am very strongly favoring 60 to the power of 12. It covers a huge range. It operates a lot like powers of 10. So much so that that's actually played into mistakes that I've made. Like looking at all of these things that are like times 60 to the power of 7 or 8 or 9 or whatever. Like finding kind of all the scalings at all the levels, and there's points where it trips me up because I'll just read it as if it's scientific notation, because it basically looks like scientific notation, but it isn't. It's not 10 to the whatever. It's 60 to the whatever, and that has tripped me up in my like one day naivety. Looking at this, but yeah. So that is actually where the 299,792,458 meters per second comes from. It is coming from the fact that meters and seconds don't actually get along, and they dislike each other so much that you can actually measure it, and the size of that dislike is 299,792,458. That's how big they hate each other. That's how much. That's what that is a measure of.